Hello everyone. Today we are going to learn in detail about AUFBAU principle and how do we represent it. Okay, so AUFBAU principle actually means what? According to the definition, it dictates the manner in which electrons are filled in the atomic orbitals of an atom in its ground state. Okay, too many words. Let's try to dissect them. Okay, first of all, it's a manner. Manner meaning it's an arrangement. Okay, it's an arrangement of what? Filling of electrons. So over here we are discussing about electron filling. In what? In atomic orbitals. Okay, let's see this atomic orbitals over here. We know there's a nucleus as an atom where we have protons and neutrons. And around the nucleus, we have got a lot of orbits. We name these orbits generally as K, L, M, so on and so forth. Okay, so what are these? These are all orbits. And it has been observed that electrons have an imaginary pathway around which they are circling around the nucleus. And these imaginary pathways are orbits. When scientists studied it further, they realized that these orbits get subdivided into various sections, namely 4 sections. Number 1, number 2, number 3, and finally number 4. What are these 4 sections named as? These 4 sections are named as S, P, D, and F. So what are these S, P, D, and F within 2 orbits? These are nothing but suborbits or orbitals. Scientists discovered that electrons are actually arranged in a systematic pattern in these orbitals. About how these orbitals work, what were the arrangement criteria, and how each orbital got its electronic configuration, we would be discussing about that in the chapter of structure of atom. Right now, I want you to focus on a very important parameter. Every orbital has a specific number of electrons that it can carry. So S orbital can carry only 2 electrons. P orbital can carry a maximum of 6 electrons. D orbital can carry a maximum of 10 electrons, whereas F orbital can carry a maximum of 14 electrons. So what did we go for? We are looking for AUFBAU principle, which states the manner or the arrangement of electrons in atomic orbital. Okay, so what are atomic orbitals? They are suborbits or imaginary pathways within 2 orbits. How many types of orbitals are we considering? We are considering 4 types, namely S, P, D, and F. Each orbital can carry a maximum number of electrons as justified. S orbital can carry only 2 electrons. P can carry 6, D can carry 10, and F can carry 14. Now, not just this. AUFBAU principle is very specific on how these orbitals would be filled in. Okay, so the basic arrangement I'll teach first, and then how do we remember it? That also I'll give you a hint on. First of all, we need to remember that there are 7 periods. Okay, 1, 2, 3, 4, 5, 6, 7. So we are going to write down 7 numbers. Under this, we need to know that 1 or the first orbit can accommodate only 1 orbital, that is 1s. How many electrons are present in 1s? 2. In second, we have 2s2, 2p6. Only 2 types of orbitals can fit. Who gave the primary notion, how these numbers were derived, and why only 1 or 2 orbital? That all is discussed in structure of atom. So we'll wait for that to come up. In the third one, we have 3s2, 3p6, 3d10. Fourth one has all the four orbitals, 4s2, 4p6, 4d10, 4f14. And after fourth one, each of the orbital has got the four division. So 5s2, 5p6, 5d10, 5f14. Sixth one has 6s2, 6p6, 6d10, 6f14. And so does the seventh one. 7s2, 7p6, 7d10, and 7f14. Okay, so how do we remember it? First orbit can accommodate only one type of orbital, that is s orbital. Second orbit can accommodate two types of orbitals, that are s and p. Third can accommodate three types of orbitals, s, p, d. And from fourth onwards, because there is going to be a huge space available, all the four orbitals can sit perfectly. Okay, so it all depends on the space that is available between the orbits. Okay, so first orbit and second orbit, these are smaller orbits. So you can't fit in a lot of orbitals within them. That's the basic notion that we can count on. Now, AUFBAU gave a great idea on how to fill these. He said, what I also quote as is a downward falling movement. That is 1s2, 2s2, then you go on like this. Now, for many, it would be like, okay, what am I doing? So give it a minute, let it sink. I'll help you with it. What am I doing is I am giving you an orientation on how to fill in the orbitals. Let's say that we have got an atom like element like sodium. Sodium's atomic number is 11. Means what? There are 11 electrons that needs to be filled in sodium. Correct? So how do we understand? All these 2, 6, 10, 14, these are number of electrons which can maximally sit in the orbital. So for 11, what do we need to do? 2 electrons plus 2. Okay, so it goes like this. Please follow the pointer. So we go something like this. We go down, come up, go down, come up, go back. Okay, so this is a backward forward orientation. Okay, so first we take the 2 electrons. Let's just mark it up with a highlighter. So here are the 2 electrons. 11 minus 2, 9. We need more 9 electrons to be filled. Next is what? This electron goes back. So this is 2. 2 plus 2, 4. Right? Now we have filled in 4 electrons. We require 7 more. So when you go back, you start filling from here. P6. We have totally filled 10 electrons. Right? Now you follow the line. 3s. But if you see, if you are noticing it properly, you'll understand that 1s2, 2s2, 2p6, 3s2. Okay, these all totally make up 12 electrons, right? 2 plus 2 is 4, 6, 10, 10 plus 2, 12. We do not require 12 electrons. How many electrons do we require? We require only 11 electrons. So what are we going to do? We are going to modify it according to our wish. So rather than writing it 3s2, we'll write 3s1. So now when you calculate, you are getting 11 numbers or 11 electrons. Okay, so how do we go about it? Always remember, whenever you are even filling in, you'll first start with 1s2, go to 2s2, come back, go to 2p6, follow the line, 3s2, come back, 3p6, 4s2, come back again, 3d10, 4p6, 5s2, come back, 4d10, 5p6, 6s2, again, 4f14, 5d10, 6p6, 7s2. So depending upon the energy, Okay, Aufbau tried to arrange or give a pattern in which electrons start filling in the orbitals. Okay, so even when we are writing configuration, we are bound to follow this pattern. Let's say we get a number like, for example, 28. Okay, so we are getting a number like 28. 28 generally is for nickel. Okay. Now, how do we go about it? Let's try to understand. Okay. How are we going? We'll start from 1s2. Then there is 2s2, 2p6. Totally they make up how much? 10. Okay. Then we have what? 3s2, 3p6, 4s2. Again 10. 20 done. 20 electrons are filled in. Now we need more 8 electrons. How do we go? We are coming back over here. So 3d10. If I put 3d10, it would make it 30, right? We do not want 30. So we'll modify the d orbital. How many electrons are we putting? We are putting only 8 electrons over here. Right? We are putting only 8 electrons. Now when you count 2 plus 2, 4, 6, 10, 12, 18, 20, 28. So you're seeing the pattern in which we are moving, right? We are going ahead, following the line, coming back, starting from the tip, following the line, coming back, starting from the tip, following the line. You need not go in a horizontal fashion. That won't be Aufbau, that would be regular filling. And in electronic configuration filling, we are bound to obey Aufbau. You can even check this way that you can go for. The general way in which even I ask my students to remember Aufbau is the snake method. What is the snake method actually? We have 1s2. Below that, you write 2s2. You write 2p6. Snake method says that below every p6, you start a new number. Okay, 2p6, you write 3s2, 3p6, 3d10. Again a p6, you write 4s2, 4p6, 4d10, 4f14. Again p6, below that new number 5s2, 5p6, 5d10, 5f14. Again a new number 6s2, 6p6, 6d10, 6f14. Then a new number under p6, 7s2, 7p6, 7d10, and finally 7f14. Okay, now let's see how this can work. For that, we can just take the help of a highlighter pen. We go like this. We go straight, come back, again straight. So this is the format in which we can go for filling. Right? You can fill in your electrons in this particular format and you would be good to go. If you get confused on how to fill in using the first method that I had shown in the previous slide, this method usually is helpful. This method would be helping you not just arrange your electrons properly in the arrangement, but also won't, you won't get confused by filling. Okay, so you go in this pattern. Fine. Now with this, I would like to conclude the lecture, but before concluding, you may try filling out for atomic number. Okay, you can try these. Atomic number 10, 30, 52. You can try filling out for these three numbers and let me know if you have understood. Signing off. Bye.